We have another example, x squared plus 20 equals 8x, wherein we are using the quadratic formula to solve this equation. You'll notice that the equation is not yet on the standard form, so the first thing that we're going to do is to arrange the equation. So we'll have an x squared minus an 8x plus 20 equals 0. So we can now identify the values of a, b, and c, wherein a is equal to 1, b equals negative 8, and c equals 20. By the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. By substitution, negative b is negative 8 plus or minus b is negative 8 squared minus 4, a is 1, and c is 20 all over 2 times 1. Next, multiplying negative 1 times negative 8 will have a positive 8. And then, negative 8 squared will have a 64. Negative 4 times 1 is negative 4 times 20 is negative 80. All over 2 times 1 is 2. We're now going to subtract the radicand. 64 minus 80 is negative 16. So 8 plus or minus the square root of negative 16 all over 2. Negative 16 is an imaginary number. But we can factor negative 16 wherein one of the factor is a perfect square that will be 16 times a negative 1. So we'll have 16 times a negative 1 all over 2. We can now extract positive 16 because it is now a perfect square. So we'll have 8 plus or minus 4 times negative 1 all over 2. And then, we now have to reduce 8, 4, and 2. All of them are divisible by 2. So this will be 4 plus or minus 2 times the square root of negative 1. Since the square root of negative 1 is equal to I can substitute it here. Therefore, x is equal to 4 plus or minus 2i. Notice that this is an I and this is an imaginary number. The roots are now x of 1 equals 4 plus 2i and x of 2 is 4 minus 2i. Let us check if the root satisfies the quadratic equation. Checking. For the original equation, if the value of x is 4 plus 2i, the original equation x squared plus 20 equals 8x. By substitution, the value of x is 4 plus 2i. 4 plus 2i squared plus 20 equals 8 times 4 plus 2i. And then we are going to square a binomial. 4 squared is 16 plus 4 times 2 is 8 times 2 is 16i plus 2 times 2 is 4, I times I is I squared. That is for the binomial. So plus 20 equals, distributing 8 inside the parentheses, we'll have a 32 plus 16i. Now, if I'm going to remove the parentheses, I will have 16 plus 16i plus 4i squared plus 20 equals 32 plus 16i. Since square root of negative 1 is equal to I, and when I square this both sides, it will be negative 1 equals I squared. Therefore, I can substitute negative 1 to I squared. And combining 16 and 20, I will have 36 plus 16i plus 4 times a negative 1 equals 32 plus 16i. Multiplying for a negative 1, I will have 36 plus 16i minus 4 equals 32 plus 16i. Combining 36 and negative 4, I will have 32 plus 16i equals 32 plus 16i. And they're equal. Next, if x is equal to 4 minus 2i, the original equation, which is x squared plus 20 equals 8x, by substitution, our x is 4 minus 2i squared plus 20 equals 8 times 4 minus 2i. Squaring this, the product will be 16 minus 16i plus 4i squared plus 20 equals, distributing 8 inside the parentheses, I will have 32 minus 16i. Now, removing the parentheses, I will now have 16 minus 16i plus 4i squared plus 20 equals 32 minus 16i. Now, combining 16 and 20, I will have 36 minus 16i plus 4. Remember that I squared is equal to negative 1. So, I can substitute I squared as negative 1 equals 32 minus 16i. So, multiplying 4 and negative 1, I will have a negative 4. 36 minus 16i equals 32 minus 16i. Combining 36 and negative 4, I will have 32 minus 16i equals 32 minus 16i. They are equal.